So up till now, what we have learned in our transportation model, what we have learned? We have learned how to understand a transportation problem and convert it to a tableau. This we know. Then we learned three methods to get the basic feasible solution. Get basic feasible solution. What were those methods? First was northwest corner method, second was least cost method, and third was Vogel approximation method. So by using any of those three methods, so whichever method we were using, the idea was to get a basic feasible solution. This is, if you remember, this is the basic feasible solution that we got in our last example using the northwest corner method. Okay, this was the case. So what is the meaning of basic feasible solution? Although these things are very clear, but I am telling you again and again because there may be confusions. What is the meaning of basic feasible solution? Basic feasible solution means the basic variables that we have finally got by whichever method we are dealing with. For example, by northwest corner method, we got this basic feasible solution, that is x11 equal to 5, x12 equal to 10, x22 equal to 5, then we have x23 equal to 15, x24 equal to 5, and x34 equal to 10. So these are the basic variables, and this into the cost, that is basic feasible solution. That is 5 cross 10 plus 5 cross 10 plus 10 cross 2 plus 5 cross 7 plus 15 cross 9 plus 5 cross 20 plus 10 cross 18. And if you remember, the answer was rupees 520. That is, the cost of transportation is 520 by this method. So up till this point, we are very clear. We have learned this, we have seen this, we have evaluated this. What we will learn now, the next part or the final part, that is how to find the minimum cost. So there we use iterative algorithm, that is transportation algorithm. What we do? The first step is using the basic feasible solution, we have obtained the basic variables. So what we'll do, we'll determine the entering variable, and second is entering variable, and second step 2 is we'll determine the leaving variable. Now entering variable and leaving variable, these are linear issues of linear programming. Now if you remember, by simplex method we had learned how to find the entering variable and the leaving variable. It's same here. The only thing is we don't have to make table as we did in simplex method. This is transportation tableau. So here the method is different and easier than the simplex method. Determining the entering variable. Why entering variable? Because we have for now we have this solution. This is the basic solution. Obviously, if we want to improve this, then we'll have to select another cell. That is, we have these cells which are vacant. That is, these are basic variables and vacant cells are non-basic variables. So what we'll do, we'll have to determine that non-basic variable that will enter our basic solution. That is entering variable. And when, let's say this, we find that x23, that is the entering variable. By a method, we find that x23 is the entering variable. Obviously, then what we'll have to do? We'll have to take one out. That will be the leaving variable. Why? Because the total number of variables, basic variables, can be n plus m minus 1. This is 3 plus 4 minus 1, that is 6. So at the most you can have 6 basic variables. So if you have a new entry, obviously one has to get out. So that is finding the entering variable. Which is the entering variable? That is variable from non-basic to basic solution. And so because of a new entry variable, one of the existing basic variable has to get out and become a non-basic variable. Clear? Now let's see the step, how we do that. In transportation algorithm, we do this by, it is called method of multipliers. Method of multipliers. Okay, what we do? First case, in case of basic variable, we take ui plus vj equal to cij. U for this part, u1, u2, u3, and v for the demand part, v1, v2, v3, v4. Okay, and u1 plus vj is equal to cij, this cost. per unit cost. This is for basic variables. I'll do, and so that you'll understand. After this, when we complete it, we'll get u1, all the values of ui, that is u1, u2, u3, v1, v2, v3, v4. We'll have all the values. Then what we'll do, we will find for non-basic variables, what we'll do? We'll do ui plus vj minus cij. We'll have ui vj from the basic variables, and then for non-basic variables we'll compute ui plus vj minus cij. It is same as we were doing in simplex method. That the only thing is it was done differently, and this is an easier method. It may seem somewhat confusing when if you are reading for the first time. If you are learning this for the first time, you'll think what I am talking of, but this is very easy. Just let me proceed and tell you how. So we'll take this ui plus vj minus cij for non-basic variables. If all these values, if you remember when we were doing in simplex method, the most positive value was taken as the entering variable. It's same here. So if all these values are negative, it means we have reached our optimum solution. That is, the solution is optimal. If we do for this in the first step only, all that we get here is negative, it means this is the basic solution. But undoubtedly, we have seen when we went through the least cost method, the price was, I guess, 475 or something. So we know it won't come negative. So the value which will be the most positive, that value will be the entering variable. Okay, so we'll decide the entering variable, then we'll decide the leaving variable. How? I'll tell you. So let's first of all take these values. You can do it on the table only, but it's easier to understand if you do it differently. See, like this, basic variables. We have 6 basic variables for this particular question. What are these? See, this is x11, x12. So x11, x12, then is x22, x22, x23, x24, and x34. So these are our 6 basic variables. I told you the equation, uv equation, what it is? It is ui plus vj is equal to cij. So here what we will have, u1 plus v1 will be equal to cij, that is 10. Now what we do, see, here we write solution, uv equation, solution. So first is, what we do, we must take one of the basic variables to be 0. So what we do, we put u1 equal to 0, set u1 equal to 0. So this means if u1 is 0, v1 is 10. Now we have two values, u1 and v1. Here it is u1 plus v2. u1 plus v2 is cij, that is 2. So here u1 is 0, so our v2 will be 2. Third, x22. So this is u2 plus v2 equal to, what is it? It is 7. The cost is 7. Now we have the value of v2 as 2. So u2 will be, I'm writing it directly, u2 will be 5. 7 minus 2, 5. Okay. Now x23. So it will be u2 plus v3 equal to x23, 9. So we have the value of u2, 5. So v3 will be 9 minus 5, that is 4. So we get the value v3 as 4. Then this is u2 plus v4 equal to, say it is 20. u2 we know is 5. So v4 will be 20 minus 5, that is 15. Then x34. So it is u3 plus v4 equal to 18. Now we know v4 is 15. So from here we get the value u3 is equal to 18 minus 15, that is 3. So from the basic variables we have found the values of ui and vi. What we do, we write it here. See, it's easier if you write it here. So u1 is 0, u2, u3. Where is u2? u2 is 5, u3 is 3. Then we have v1, v2, v3, v4. v1 is 10, v2 is 2. This is 10, this is 2. v3 is 4. v3 is 4 and v4 is 15. So we have got the values of u1, u2, u3. u3 is 3, okay, and v1, v2, v3, v4. So we get the values of u's and v's from the basic variables. Okay. Now next, I told you what we do. We'll find the entering variable, that is from non-basic variables. So non-basic variables. See, non-basic variables. We have 6 non-basic variables. This is x13, x14, x13, x14. Then x21, and then these 3 cells: x31, 32, 33, x31, x32, x33. Okay. Now what we have to do? We have to do ui plus vi minus cij. We have to find this value. So let's start. See, 1 3 here, this one. So what this will be? u1 plus v3, u1 plus v3. So 0 plus 4, 4 minus cij, 4 minus 20 minus 16. So the value is minus 16. Next thing, 1 4. So u1 is 0, v4 is 15. So 15 minus 11. So this is 4. Clear? See, u1 plus v4 minus cij. So it is 15 minus 11. Then x21, this one. So it is 5 plus 10, 15 minus 12. So it is 3. Then x31, 31. So this is 3 plus 10, 13 minus 4. 13 minus 4 is 9. Okay. Then x32, 3, 2, 5. 5 minus 4 minus 9. x33, this one. 3, 4, 7. 7 minus 16. 7 minus 16 again minus 9. So I told you the whichever value is the most positive, that is taken as the entering variable. See, out of this, this is 9. This is the largest value, largest positive value. So our entering variable is x31. So this is our entering variable. That is, this variable will enter into the basic feasible solution. Clear? So up till now, what we did? From basic variables, we found the values of u1, u2, u3 and v1, v2, v3, v4. Then for non-basic variables, we found ui plus vi minus cij. So these are the values. The value which is largest positive value. If we would have got all these negative, then it means the solution is feasible. It's not. We have 3 positive values. So highest value, that is the entering variable. So up till now, what we have done, we have identified the entering variable. Okay. Now what we'll do? We will find the leaving variable. But before that, one thing to be understood here is u3 plus v1. This is the entering variable. That is u3 plus v1 minus c31. This is what? u3 is 3, v1 is 10 minus 4. That is 9. What is the meaning of this? This is the cost that we will be saving. That is, if the amount of items, the number of items that we will be sending through this port, this unit into this will be, if this is 2, if finally we get that x31 is 2, then 9 into 2, that is 18 rupees will be the saving. So remember this 9. When we will find the value of this, we will multiply it with 9, and so our cost will reduce by this. Clear up till now? Now I am going to find how, or we'll understand how to find the value of the entering variable. See, what we do, we say let the value of this be what we use a particular term, that is theta. So we say let it be theta. We don't know what is x31, let it be theta. Now what we have to keep in mind is that supply and demand should be undisturbed. That is, it can supply only 10 atoms. This unit has demand of only 5 atoms. So this means this plus this can be this only, and this plus this can be this only. So this cannot be disturbed. This is the first important thing to keep in mind. Second is, none of the values can be negative. Xij is always greater than or equal to 0. This is condition for linear programming. So these conditions have to be taken into consideration when you will be finding the value of theta. This means you cannot have any negative value here. This is basic linear programming. So what we did, we said this is theta. So what we do actually, if this is theta, then to balance it, we have to do this 10 minus theta. So that theta plus 10 minus theta is equal to 10. This is undisturbed. Now this is 10 minus theta. This means this has to be this plus theta, because if theta is 2, this becomes 8, then it must become 7. So corner points have to be balanced. So this, because of this is this. If it is 5 plus theta, obviously this will be 5 minus theta, that is plus theta minus theta has to neutralize. Minus theta, so you'll have to put plus theta, and plus theta, so you'll have to put minus theta. So this is the loop that is actually created. This loop, you have to understand, this cannot be diagonal. That is, you cannot go like this. This is always, the lines are always horizontal and vertical only. So this is a closed loop. We have used this. Now you know that xij has to be greater than or equal to 0. This means, if to satisfy this, theta has to be greater than or equal to 0, because it is a variable now. So similarly, 10 minus theta has to be greater than or equal to 0. Then let's not talk of 5 plus theta. Why? Because we don't need it. You'll understand it. 5 minus theta again. 5 minus theta has to be greater than or equal to 0. Let the plus, leave the plus. Then 5 minus theta again. 5 minus theta greater than or equal to 0. Why I didn't take plus values, 10 plus theta or 5 plus theta? Because that is not required here. What we require is this minus this, so that we are able to find the maximum value of theta. See, from this equation, if we say that the maximum value of theta is 10, then this will be minus 5. So the value will become minus 5, less than or equal to 0. So this cannot be the case. The only possibility is that the maximum value of theta can be 5, so that this becomes 0. It can be 1 to satisfy this, 2, 3, 4, 5. The maximum value is, for these two, is theta max is equal to 2. So this is the maximum value that theta can have, and that will be the value of our entering variable, that is x31, which is theta, will be 5. This we have found the value. Okay, so let me rub it. See, theta is 5, so I'm writing 5. 10 minus 5, 10 minus theta, so this will be 5. 5 plus 5, 10. 5 minus 5, 0. 10 plus 5, 15. 5 minus 5, 0. See. So this is 5. Now remember that I had told you 9. So 9 cross 5, that is 45 rupees we will be saving. That is, when we have chosen this, this will save this minus 45. That is, new cost will be 520 minus, that is 475. This is the meaning. So we have found our theta, that is the entering variable, and the value of the entering variable. What we have found? We have found the entering variable, which is x31, and we have found the value of this entering variable, which is equal to 5. Okay. Now what will be the next step? The next step will be to find the leaving variable, which will be leaving, because now we have 1, 2, 3, 4, 5, 6, 7. So one has to leave. When this has entered, one has to leave. Now you see there are two values of 0, this and this. Any of the two can leave, but here we don't decide arbitrarily. Most of the times we decide arbitrarily to break the tie. Here we don't decide in that way. We take that value which has the higher unit cost. See, here the unit cost is 10, here the unit cost is 7. This is higher. So what we do? We make this, that is x11. So x11 is the leaving variable. Okay. So after doing this, we have a new basic solution, which is this. See, our basic variables are, this has gone, this has entered. So these are same, and this is a new one. So this is our new basic solution. Using this, our cost is 475. Is it the least, or we can go even, our cost can be reduced further? How can we check? We'll again do this. We'll take u1, v1 again, and then for non-basic, if they all are negative, then obviously this is optimum. If they are not negative, then again one will be a new entrant and another will leave, and then we'll see. Clear? So this is the iteration. Clear? First step. Now we'll enter into the second part. We'll recheck whether it is optimum or not. Okay. Now let's again take u1, u2, u3. Obviously this will take 0, this will find, and then we'll see what is v1, v2, v3 and v4. So we start with the basic variables of this solution. Basic variables. What are basic variables now? x12, first one, then x22, then x23, x24, then x31 and x34. UV equation, that is ui plus vi equal to cij. So here we set u1 equal to 0, therefore v1 will be v2, not v1. v2 will be, okay, let us write the complete equation. u1 is equal to 0, we don't know the value of v2, I'll be writing like this so that it is clear. This should be equal to c12, that is equal to 2. So from here what we get? v2 is equal to 0. So we have two values, u1 equal to 0 and v2 equal to 0. Now here what we get? u2 plus v2. See, u2 plus v2. v2 we have what? So it is 2. v2 is 2. This is equal to c22, that is 7. So from here what we get? u2 is equal to 5. Now this is u2 plus v3. u2 is 5 plus v3, x23, this one. So value is 9. So what is v3? 9 minus 5, 4. v3 is 4. Then u2 is 5 plus v4 is 20. From here we get the value of v4, that is 20 minus 5, that is 15. Then u3 plus v1. v1 is, where is v1? We don't have the value of v1 up till now. See, okay, let it be u3 plus v1 equal to 4. Let's see, we don't have any of the two values. Let's see if we get the value of u3 from here. This will be u3 plus v4. We have the value v4, 15. That is equal to 34, say x34, it is 18. So from here what we get? u3 is equal to 18 minus 15, that is 3. So here we can write the value of u3, that is 3. So our v1 is 4 minus 3, 1. So we have got the values. u1 is 0, u2 is 5, u3 is 3, v1 is 1, v2 is 2, v3 is 4 and v4 is 15. Okay, so we have written this from the basic variables. Now what we'll have to do? We'll have to see for the non-basic variables. Non-basic variables. And what we'll be doing? ui plus vj minus cij. We'll find this value. So what are the non-basic variables now? x11, x13, x14, then x21, then we have x32, x33, 1, 2, 3, 4, 5, 6. So these are non-basic variables. This will be u1 plus c11. So u1 plus v1 minus c11. u1 is 0 plus v1 is 1 minus cij, that is 10. This is equal to minus 9. So first is minus 9. x13, 1 is 0, v3 is 4 and that is 20. So it is minus 16. 1 is 0, v4 is 15, minus 11. So this is 4. See, this is positive value. So this is not optimum. We'll have to do it again. x21, u2 is 5 and v1 is 1, minus 12. So 5 plus 1 minus, this is minus 6. Then x32, that this is 3 plus 1, no sorry, 3 plus 2, minus 14, it is 5. So this is minus 9. x33, it is 3 plus 4, 7, 7 minus 16, that is minus 9. So still we have this value which is positive. So x14, this will be our new entering variable. That is, this value is our x14 is our new entering variable. So what we'll do, let's find out the value of this entering variable theta. So what we do, see, this is already covered, this one, this is the new entering variable, and this is covered. So what we do, we take horizontal only. So this will be our new loop, this is our new loop. So let this be theta. So this will be 15 minus theta, this will be 0 plus theta, this will be 10 minus theta. So that supply demand is equal. So this means 15 minus theta is greater than or equal to 0, then 10 minus theta is greater or equal than 0, and theta is greater than or equal to 0. Okay, so theta max will be 10, because otherwise if we take theta equal to 15, this will be negative, which is not possible. So theta max is 30. So this is the value, 10. So this is the value of x14. So what we do, we write 10. Then this is 15 minus 10. So 15 minus 10 will be 5. This is 0 plus 10. So 0 plus 10 is 10. This is still 15, nothing to do. And this is 10 minus 10, that is 0. See, this is 0. Now we have only one 0 this time. We don't have two zeros, there is no tie. Therefore, our living variable will be this one, x24. So from this we find that x24 is the living variable. Okay, and if you want to know what reduction in cost we have got, so we'll do this plus this, that is 0 plus v4 is 15. So 15 minus this 11, that is 4 into 10, 40. That is because of this we have reduced the cost by further 40 rupees. That is, the cost is rupees 435. So from 520 we have come to 435 by selecting this as new variable. Okay, but is it optimal, or we'll have, is it optimal or not? How we can find? We'll again find these, and from here we'll find whether any of the value, all the values are negative or not. Okay, let's see. So first of all, these are our new basic variables, these 6. So for basic variables, we'll start with our basic variables, that are x12, x14, x23, this is x22 is also basic variable. So x22, then x23, then we have x31 and x34. This has left, this variable is gone. So these are the basic variables. So what we do, we do u plus v equal to c. So this is u1 plus v2 equal to u1 plus v2 equal to 2. See, u1 is 0, so v2 is 2. Now here it is 0 plus v4 equal to 11. So this is, from here we get v4 equal to 11. I am writing it, v4 11, and this is v2 is 2. Then next, u2 plus v2, x22 is 7. This is 7. Do we have any value? u2, v2? No. Okay, let's go ahead. This is u2 plus v3 equal to x23, that is 9. We don't have any value. Again, u3 plus v1 is equal to 4. Do we have any value? v1? No, we don't have any value. Okay, then u3 plus v4 equal to 18. We have the value of v4, it is 11. So from here we get u3 is equal to 18 minus 11, that is 7. So u3 is 7. Now here we have u3. So this is now 7 plus v. See, 7 plus v1 is 4. This implies v1 is 4 minus 7, that is minus 3. Then we have v3, u2. Which values we have? v1, u3, I am writing it here. v1 is minus 3. Then u3 is 7. And u2 we don't know. Okay, we have these values. v3 we don't have. So u2 plus v3, we don't have u2, v3. u2 plus v2, we have the value of v2. See, it is 2. So from here we get u2 is equal to 5. Okay, so now this is 5. So V3 is 9 minus 5, that is 4. So this is 4. So we have obtained the values of u's and v's. Now let's see for non-basic variables. That will tell whether our solution is optimal or not. So non-basic variables, they are x11, x13, then x21, x24, x32, x33. So these are the non-basic variables. Let's find the value of u plus v minus c. So see, 1, 1. So 0 plus minus 3. So minus 3 minus 10. What it will be? It will be minus 13. 1, 3. 1 is 0 and 3 is 4. So 4 minus 20. It is 16. 2, 1. 2, 1. 5 minus 3. So it is 2. 2 minus 12 minus 10. 2, 4. This one. It is 5 plus 11. 5 plus 11 is 16 minus 20. It is minus 4. 3, 2. 3, 7, and this is 2. 7 plus 2, 9. 9 minus 14, that is minus 5. 3, 3. See here. 7 plus 4, 11 minus 16, minus 5. Now you see all the values are negative. All the values are negative. This means whatever the basic solution for which we have found these values, this solution is optimum. So now we know this is the optimum solution. We have calculated the cost also, that is equal to 435. If you don't believe, let's do it again. The cost will be 5 cross 2 plus 10 cross 11 plus 10 cross 7 plus 15 cross 9 plus 5 cross 4 plus 5 cross 18. So it comes to 10 plus 110 plus 70 plus 135 plus 20 plus 90. See, 90 and 10, 100. 100 and 110, 210, then 210 and 70, 280, 280 and 20, 300, 300 and this 435. So by using our transportation algorithm, we have found the lowest cost that is possible for this problem, which is rupees 435. Basic solution that we had got from by the northwest corner method, it was 520. By least cost method and Vogel approximation, I guess it was 470 or 475. So by using the algorithm, we have further reduced the cost by 30-40 rupees, which is finally equal to rupees 435. So I guess you have understood this concept. Revise this 2 and 3 times. This is very easy. Okay.